This lesson, we are looking into conditional probability. Before we begin, I dare you to say this quickly 3 times, like a tongue twister. Have a go first. I'm not if you could hear my accent, I'm not a English native speaker, but let's have a go. To find a probability that you see this tree twice, you probably need to use this probability tree. Trust me, when I make this meme, my tongue literally made a tie. Anyway, um, learn objectives. So we're going to learn, understand, and calculate conditional probability in the context of changing probabilities. So we're not looking too much detail into actual wording of conditional probability because you will learn this topic has a lot more depth, even stretching out into A level, into university, and furthermore. So not gonna go into that details, but we're learning about changing probabilities and apply conditional probability to solve problems. So before begin, have a go at the starter question below. Just have some basic tree diagram question and probability question. When you're ready for the answer, you can press play. Question 1, 0.7 times 0.4 because a pass and a pass. So we multiply the numbers on the branches. And then for the second one, either one of them, either passing maths or English. So the first one means you pass maths, but you fail English. Or you could do failing maths, which you shouldn't after watching this video, and pass English. So that's why when you have 2 branches, you have to add them up to find the total probability. So for each branch, multiply numbers 0.7 times 0.6, 0.3 times 0.4, and then add them up. Okay. Question 2. Happy Dotty randomly picks a card from a full deck of playing cards, put it back, and draws another one. What's the chance of winning 2 cards with hearts? Now, you should know there are 52 cards in a pack of cards. Okay, 52. And in those 52, now we're not counting jokers. Jokers not traditional maths playing cards. So there are 4 suits, and each suit has 13 cards from ace all the way to king. So the 4 suits are, if you go down to the page and see below, and here you can see the hearts, the spade, the diamond, and the club. So to get a card with hearts the first time is 13 out of 52 because 13 hearts out of 52 cards, or it's 1 suit out of 4, so it's a quarter times. Next time when you put it back in, you have a full deck of cards again, so a quarter times a quarter, which in total is 1 over 16. So let's look at the notes. Conditional probability involves finding the probability of an event given another event has occurred. So what it means is, it means conditional means it's based on a condition, previous condition. So let's have a look in here. We've got 2 scenarios. Scenario 1, we draw a card, we replace it, means we'll put it back in, we draw again. Another scenario, we draw a card, but this time the card is not replaced, and then we draw again. Now, one of them describes conditional probability. Can you guess which one? It is scenario 2. The answer is scenario 2. But why? Because if you're not replacing the card, because when the card is not replaced, when the drawn card is not replaced, there is one less card after the first draw. So in the beginning, if you remember, there are 52 cards in a pack of cards. If you do not replace it, that means the second time it'll be out of 51 because it'll be 1 card less. So that's conditional because what happens before actually affects what happens after. Similar situation would be like, depends on the weather, sunny or rain, it affects the probability that you go to school on time, because on a sunny day, the traffic are more likely to be clear, but on the rainy day, more accidents are likely to happen on the road, and therefore more traffic, and therefore more likely for you to be late in school.
No school?
So these are called conditional probability. It's based on the certain conditions. Now, note, there is an algebra version of this topic which requires you to do with quadratic equation as well. So this is a grade 9 topic. Let's look at the first example together. there are 6 normal jelly beans and 4 bamboozled beans in a box. Now, if you don't know what a bamboozled bean means, um, jelly beans used to, or not sure if they do still do it now, do a box of bamboozled beans where they mix a good mixture of normal jelly beans and what we call bamboozle beans is like a weird flavor, like pencil sharpening flavor, boogie flavor, but they have the same color as a normal one. So when you pick one out of the box, you never know if that's a normal flavor or then bamboozle flavor. So I remember back then when I was in school, everyone used to have one pack. The funner teachers will actually join with us and take a gamble and pick one. Um, I still remember the phase that I see when I see my mom eating the bamboozle one. Obviously, she doesn't know about it, right? So it was so funny. Anyway, at the end of every revision session, Belle would take a break and take one bean from the box and eat it to motivate herself. Motivating quotation being because if she picked a good one, I actually got a friend doing this before. If she got a good one, then she was like, "Yes, finally I got a good one out of I've done a good revision session, so I've got a good one. That's, it keeps you motivating. But if she hasn't got a good one, or got a bamboozled one, then she'll more likely remember the ugly flavor of the beans rather than the painful experience revising in the library. Well, she shouldn't be eating in the library, but shh, let's keep it secret. So she did 2 revision sessions. So A, draw a tree diagram to illustrate the scenario. So she did the first revision session, so first revision session, and the second revision session. So during the first revision session, she could have picked a normal one or a bamboozled one. Her chance of getting a normal one is 6 out of 10 because there are 10 in total, and the chance of getting a bamboozled one will be 4 out of 10. Right? Now, for the second time, now because she takes one and she eats it. That means for the second time, she could also get a normal one and bamboozled one, a normal one and bamboozled one. But this time, the probability will be out of 9. So what I would suggest you do is, I would suggest you to do straight away one less, make denominator all out of 9 first. Then you can think about scenario by scenario. Now, the first number here, the first time she got a normal one. That means the second time it will be one less normal, so it will be a 5 out of 9. If the first time she got a normal, that means the bamboozled still have 4 in the box. So the second time when she picked it, there are still 4 bamboozled on there. The way to remember is just remember one thing. Each branch in a tree will always add up to 1. So you can see these add up to 1. 6 over 10 plus 4 over 10 will be 1. 5 plus 4 over 9 will also be 1. So this one, now for the second branch, for the bamboozled branch, the first time we'll pick a bamboozled, so therefore there were still 6 normals in there. But if we pick bamboozled the first time, 4 minus 1, there'll be 3 left. Okay, so of course this will also add up to 1. So that's part A. Part B, work out the probability that Belle is bamboozled twice. Bamboozled twice, so we go through the bamboozle route, bamboozled. So that will be part B. We multiply the fraction probability across the lines. So 4 over 10 times 3 over 9. We can put a calculator or not. So 4 times 3 is 12 over 90. Now in probability, you are not usually asked to simplify the fractions because in probability, having an unsimplified fraction also tells you some important information. Like in here for denominator, a 90, it means altogether there in total of 90 possibilities. So in probability, we tend not to simplify fractions, but we can also simplify fraction just to give people an idea how likely one thing happens. So C. So you can simplify this, don't get me wrong, okay? But I'm not going to do that in here. Part C. Work out the probability that Belle is bamboozled at least once. So bamboozled at least once means she can get the normal in the first round and get a bamboozle for the second round. So we can do probability of so we can do a normal and a bamboozled once. So normal is 6 out of 10, bamboozled is 4 out of 9. So multiply that multiply that. That will give you 24 over 90. Or you can get the first time bamboozled and the second time normal ones. So 4 out of 10 times 6 out of 9, that's 24 out of 90. Or because it says bamboozled at least once, means she can be bamboozled twice. That would be quite disgusting. Literally disgusting flavor, disgusting. B and B, so will be 4 out of 10 times 3 out of 9. That will be 12 out of 90. So altogether, the total probability is 24 plus 24 plus 12 will be 60 out of 90. Or you can simplify in 2/3. That means she's very likely more than half a chance getting bamboozled at least once. Um, is there a smarter way of doing it? Of course. Probability of bamboozled at least once means you can work out a probability that she gets no bamboozled. That means she picked normal twice and subtract away from 1. So if we do it another way, so you can do, so her chance of getting no bamboozled means normal and normal is 6 out of 10 times 5 out of 9. That will be 30 out of 90. So therefore, the probability of getting bamboozled once will be 1 minus 30 over 90, which is same as 60 over 90. So that is a quicker way, of course. Here comes practice question 1. Have a go at the question. When you're ready for the answer, you can press play. So here are the answers. The tree diagram, just be careful. There's 8 counters in the back, so that's out of 8 altogether. So 5 8, 3 8. Second draw will be out of 7 because without replacing it, I've kindly bolded it for you. Sometimes quite well hidden in the question, so make sure you read the question carefully. Out of 7, out of 7, out of 7, out of 7. And then that's after draw 1 red, it becomes 4 red. And then 4 of 7, 3 of 7, so etc. So, right, so you can have a look. Practice question number 2. This time, the question did not ask you to draw a tree diagram. So you're not really required to do a tree diagram. It sometimes it's quicker not to draw a tree diagram as well. The tree diagram is just for you to understand why the numbers go down by 1. But here you can do it without it. Try to do it without it. Another type of question you could ask is when they say 2 of these counters are picked at the same time. At the same time means you're not replacing them. Okay, so right, so pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. I use S for squares, C for circles, and T for triangles. So probability of getting 2 squares, the first time is 4 out of 15. The second time will be 1 less counter, so it'll be 15 to 14, and 1 less square counters from 4 to 3. Similar for circle and circle, triangle and triangles. These fractions are simplified because I use a calculator. If the question requires a calculator, use it, why not? So when you add them up, and my answer is 31 out of 105. If you do it without a calculator, just simplify, see if you got the same answer. The last practice question, this time again with a calculator, another very common type of question you might see in the exam. So Mr. Words, with a Z, has these letter tiles and he's going to pick 3 tiles, one at a time, randomly, without replacement. Calculate the probability that all these 3 tiles are vowels and probability that exactly 1 V tile is picked. Have a go at the question. When you're ready for the answer, you can press play. Here are the answers for question A and B. So A is 1 over 30 and B is 7 over 15. Now I wrote out the solution for A, but I do want to go through B. So if your answer is correct, just move on. I do apologize for my superb coloring skills of the box. I'm never a good colorer. Is that a word? Anyway, I just couldn't. Question B. Calculate the probability that exactly 1 V tile is picked. So to pick exactly 1 V tile, we do have a few ways of doing so. The first way is because depends on the position of the v tile is picked, you can have different, probabilities calculation. So the first one is if we pick the v the first time, and then the second time we can't pick a v, and the third time we can't pick a v. Right? So the first time that we can pick a v is there are 2 v's out of 10 tiles, so 2 out of 10 to begin with. Second time it's not a v tile. So now in the 10 tiles, there are 2 v's and 8 non-v's. Okay, so if the first one is a v tile, that means the second time there will be 8 non-v tiles left. However, we pick the first one, there'll be out of 9, and the third time we'll pick it will be out of 8. So 10, 9, 8, and then there will be 8 non-v tiles. After we pick do the second pick, that means we've picked a non-v tile, then we're down to 7 non-v tiles. So altogether, we've got, if you put in a calculator, you get 7 over 45. Just put in a calculator. Or we can pick the v tile in a second time we picked it. So the first time we pick a not v, and we pick a v, and then a not v. So again, we know the first time we got 10 tiles, second time 9 tiles, and the third time 8 tiles. To begin with, we have 8 non-v tiles, and then we still have 2 v's in there. And the third time we pick it, we got 1 less non-v tiles. So put in a calculator, you get 7 over 45. Similarly, for probability, this time getting v on the last chance, on the last pick. So not v, and v. 10, 9, 8. So first time we got 8 non-v tiles, second time we got 7 non-v tiles, and then we got 2 v tiles. You see 7 over 45. So altogether, if we add them all up, so sum means add them all up, 7 over 45 plus 7 over 45 plus 7 over 45, that will give you 7 over 15 as a final answer. Now, what's the quickest way? Of course, once you read, if we have a look of the numerator, denominator carefully, if we look at denominator first, all of them are 10, 9, 8, right? So denominator must always be 45 before simplified. What about the numerator? 287, 827, 872. It's still the same 3 numbers, but it's just in different order. However, when you multiply them, it doesn't matter what order you multiply them from. As long as they are the same numbers, you'll get the same result. What I'm trying to say is, for example, if I ask you work out 3 times 2 times 1 and 1 times 2 times 3 or 2 times 3 times 1, they all give you the same thing, which is 6. So therefore, the shortcut is, actually, we know 7 over 45 will be the same across the 3. We could have done 7 over 45 times 3, and that gives you 7 over 15 to begin to finish off.